Okay, in this video we're going to talk about proof and equivalence. So this is the chain of reasoning that relies on the facts that two equations are equivalent if they have precisely the same solution. Two functions p of x and q of x are equivalent if p of x is equal to q of x for all x element of real numbers. To main mathematical equivalence, we can add, subtract from both sides. Multiply and divide from both sides that are non-zero terms. Substitute for an equivalent subterm by replacing terms by factored or expanded form. So what we have, completing the square. This is, just recall, I'll put a video in for this, that it's taking this term, actually I'll just highlight it, take this coefficient, the coefficient of the second term, and dividing it by 2. So this is because ultimately you want this whole expression, this left-hand side, to look something like whatever this is, something squared. That's it. Right? And then you would have this term left over and it would be pushed over to the other side and you'd have something over here, whatever that is. But you're trying to, this is completing the square, making it squared, right? So that's the essence of it. But in the video, if you don't remember, I'm putting up a completing the square video and you'll get the idea. So what I'm going to do is rewrite the expression. So we have x squared. This is a minus 2 x plus a equals 0. So what we're going to need is this first part, squared, plus I need this to be halved. So what I'm going to do is a minus 2 divide by 2 x plus, close the bracket over here, but I'm going to have to, whatever goes in here, I have to subtract it on the outside as well. So a minus something is going to be equal to 0. I have to, because these two, if I'm putting something in here, I have to balance them out. So this is going to be, whatever you half, this coefficient, the middle coefficient, you take half of it, you square it right here. So it would become this, a minus 2 all over 2 squared. Right? This would be right here, a minus 2 all over 2 squared. So then this, I can now compact it to make it look like that, because you just expand them out, right? So that's just FOIL. So really what I would get here is x plus a minus 2 all over 2 squared plus a minus, well, I'm going to just expand this out, so I'm going to add one step here. You don't have to necessarily. And then that is squared at the top, and the numerator is squared, so it would be 4 equals 0. This, now I put everything, I put this onto the right-hand side. So then I'm going to get x plus a minus 2 all over 2 squared is equal to a minus 2 squared all over 4 minus a. There we go. Now the thing is, there's your p of a, let's say this is your p of a, and this is your q of a. These two would be equal, right? That's basically the idea that we're trying to get to. So this is, because what we want to know is this right here, positive integer, the smallest positive integer. So this is a has to be some element of integers for which this statement is true. So we want to find the values of x that would allow us to have 0. So, but we need to make sure that a, it's going to be true. Positive integers a. So we need this a is going to be greater than, right? A here is just some constant. It's going to be some integer. So let's see what integer it might be, right? So for that to happen, for this to have a solution, because we need this to be greater, this needs to be greater than or equal to 0 for this to be true. So what we have is then this statement. So it's only true if and only if. So this is, it implies if you have this, so find the smallest integer such that this is going to have a real solution. Okay. If and only if, this can only happen if a plus minus 2 squared divided by 4 minus a is greater than or equal to 0. Now I just multiply through by 4, so this is going to be a minus 2 squared minus 4a greater than 0. There we go. So what I'm going to do here is I'm going to expand this. So if I expand this, I'm going to have a squared, right? This times that times twice. This minus 2a, that squared. So this is going to give me that squared. So plus 4 minus 4a greater than 0. Right? Yeah, that should do it. This, subtract that, should give me oh no, this is times 2. Sorry, this is, I forgot to multiply this by 2, so you're going to have not 2 here. There we go. So just remember, if you can't remember this, so it's just a minus 2, a minus 2, multiply a squared. These two is minus, you're going to have 2 minus 2a and another minus 2a. So, or you can think about this. It's these two multiplied together, so it's this one multiplied by that, times what you have in the exponent, which is 2. So really, you're just saying, well, it's going to be a times minus 2a and multiplied by the exponent, 2, right? So there's your 2, the exponent. There, that gives you your minus 4a. So then this comes together and you're going to have 2a squared minus 8a plus 4 greater than or equal to 0. So now we can factor that, which is going to be a. This will be or we can at least try and factor that. Oh no, we have to again complete the square. This is not going to be factorable. We're going to need to complete the square for this one too. So what happens here is a squared. So 8a plus, take half of that. So this is going to be minus 4 squared plus, this is going to be 4. This is going to be minus, you're going to have to subtract minus 16 because that's 16 right there, greater than or equal to 0. This is then going to give you a squared minus 8a. This is going to give you your plus 16. So notice you can balance that. Plus 4 minus 16 greater than or equal to 0. There you go. Now what you see is you're going to get a squared. And here we're going to keep the minus 16. So this one right here, so notice we're going to keep this right here. So this is then going to be, if that's 16, so we will have, oops. So we're going to have this. So we should have a plus, this will be 4 squared. And right here is going to be plus 4 minus 16 greater than or equal to 0. This I now have a plus 4 squared. This is then going to be minus 12 greater than or equal to 0. This, then we can say 4 squared greater than or equal to 12, right? Now what I can do is square both, like take the root of both sides. So I can have a plus 4 is greater than or equal to plus or minus root 12. So notice what we have. You either have two cases. A is greater than or equal to 4. Oh, this should be, oops, nobody noticed this. I only caught it here because it's minus 4 here, right? So it should be that this should be negative. That's my only problem. Minus 4, minus 4, minus 4. Remember, it's right here. You can see that it's squared. Notice I just missed that. That's an oops. So that you have it right here. You can see that. I just didn't think of that. I just made a positive accidentally. There it is. So that should be minus 4 because it's minus 4 right there. So that's okay. So then this is just going to be minus 4, but we still see that 4 plus root 12, or you have a greater than, or sorry, less than, or because it's yeah, a is less than or equal to 4 minus root 12. There you go. So that's what it would be. So we would have here so if you put this into your calculator, you're going to have this approximately equal to, so this would be, like, this is an example of where you could have a calculator. This would be a calculator problem because of this. So then this would be, gives you 7.46. That would be approximately 0.536. And there you go. Right, for those two guys, there we have it. So a, the closest integer that we would have is 8. Because if I actually put 7, it would give me something underneath, like below, right? So it would not give me an a that's positive. So we want something the least possible, then it would be, a would need to be equal to 8, right? That would be the least value, the smallest positive value. So smallest possible value integer, smallest positive value a element integers, which is a is equal to 8, right? So that would be the solution.